right, so we are set and we are recording and we're going to do this. So, a couple things here. Number one, you're looking at the major question I get all the time is when I read the problem, I don't have any idea what the hell formula I'm supposed to be using. Okay, that's the number one thing I hear. And I get that. So, first of all, you got to know when the test approaches, are you doing a confidence interval or are you doing a hypothesis test? And how do you tell the difference between them? Well, there's a couple ways to do it. Number one is confidence intervals are A, B, C, D, E. So when you look at a sheet of paper, if it says A, B, C, D, E, you can make a summation that that's probably a confidence interval. Hypothesis test is A, B, C, D, E, F, G. Now, you do not get the right to go in and erase any of my letters. I mean, I've had people do that. You know, like, oh, you added too many. No, you don't want that many. No, if I put them down there, I wanted them there, so leave them alone. Okay? Now, the other thing is, you have to read the problem. I probably should be pausing this, but you know what? I don't care.
Would the confidence interval give you a percentage as well?
Notice this one. This is a confidence interval from one that we did a while back. Notice what it says. Use the values to construct a, there's some critical words, confidence interval. When it says confidence interval, that goes like this. I think we're supposed to use confidence interval. Now, I'm not being a jackass. I'm being serious. Because there are people who don't know the difference. And they look at them and they don't know the difference. Now, I'll draw your attention to the sheet. I'm giving you a formula sheet. It looks like this. When you see less than, that's a confidence interval. So if you see a problem like construct a confidence interval, and then you see less than, that's a confidence interval. So don't go down and try to use this formula for a confidence interval. There's no less thans there. Okay? Now, go back to the original problem. The original problem said, bless you. We're going to test the claim. Now, this becomes, I don't want that, I want this, I want this. These words right here are critical. Whatever comes after that is the most telling thing of all. Test the claim that the amount of time is less than 30 minutes. And that's the mean amount of time is less than 30 minutes. Okay? So that's the mean is less than 30 minutes. So immediately we have to put in HO and H1. So we got HO. We got H1. Is this going to be HO or is this going to be H1? It's H1. Now, I see a lot of people do this because they're not really certain what the hell to put there. And they're just like, the hoe is 30. That's wrong on so many levels. Okay? You have to say, what is it? It's got to be one of these three things. Either mu, P, or sigma. It cannot be X bar, it cannot be S, and it cannot be P hat. Okay? It cannot be any of those. If it's any of these, flower power. Okay, just start praying because you're so far screwed up, it's unbelievable. And I say that with a great deal of love. Okay? Anytime I see people putting X bar there, I'm just like, Lord, they have no idea what's going on. Okay? I mean, there's like no way nice to say that. It's just you don't. This has got to be mu. Okay? Part B. Is this going to be a left tail, right tail, or a two-tail test? Left tail. Okay. And I say that, I'm kind of an ass, and I'm sorry. Because some of y'all are doing it probably. You're going like this. Well, thanks for telling me I don't know what I'm doing. You need to know that on test day, which ones can you put there, which ones can you not put there. Okay? I mean, it's okay to do it today. It's just not okay to do it Wednesday. Or tomorrow, depending on what day you come in. Their class is tomorrow.
So can we come in tomorrow and look at the test during that class period?
Sure, you can take it tomorrow.
And then take
No.
it Wednesday?
But you can feel free to come by tomorrow and take it if you want.
What time can we take it tomorrow?
10:30? 10:30 to 12? No, 10:30 to 11:30.
10:30.
Yeah, we're going to have class after it's over. Part C. Okay. You got to know the formula. Now, the formula is written on that sheet of paper. Is this one. Not that one. JK, it's on this side. It's this one. Okay. Now, why are we using this one? Let's look. It's a hypothesis test on the mean. The question that we have to ask is sigma known? In this case, it told us sigma was equal to 6. So because of that, sigma is known. And you'll notice that what I said was, if so, the sigma n will be bigger than 30. Okay? So that's the formula you're going to use. So z equals x bar minus mu. Now, I'll tell you, 20 years ago or however long it was, I was taking thermodynamics. And I say this, and I know we're recording, but this is an important thing. I remember taking thermodynamics, and the instructor said, I'm going to give you the formula sheet for the test. And I remember thinking to myself, my God, what is this, a joke course? You're going to give us a formula sheet? How hard can that be? All right, by test 1, I learned exactly how hard that could be. My dumb theory, and I say it was a dumb theory because there's no other way to describe it, my theory was dumb. I thought, well, hell, if he gives us a formula sheet, I can just look at the formulas, look at the problems, and go like this. X bar, sigma, n, X bar, there's the one I need. Oh, no. When you get to the test, just because I give you all the formulas, I might give you other information you don't really need. So don't just assume that just because you have the formulas and the pieces that you can just go plugging and chugging and figure out which one's which. Love you. Okay? But you'll quickly get yourself in all kinds of crap. All right? So you got to know which ones you're looking at. With that being said, let's do D. D. Z equals 20 minus 30 divided by 6 over the square root of 45. Now, somebody asked me earlier, how do you know n's 45? I didn't see that anywhere. 45. It's only funny if it was you to start with, right? I think what happens is because I put the other symbols in, everybody just kind of starts naturally wanting to look for n. Where's n? Where's n? And because I hand wrote it in there, you kind of just skipped it. It's all good. Okay. Now, when you do that, you get negative 11.18, I think. Okay, we had done that earlier. Now, as a method of kind of check yourself here, Corey, if this number is negative, this number here should be negative too. Like, you probably ought to not get a positive number for this and have a negative number for that. If that happens, know that you jacked that up good. You did. I mean, like, you just screwed that up. Somehow, some way, you jacked that up pretty damn good. Because that should never happen. And if it does happen, then do me a favor. Just make them the same sign one way or the other. Like, if this somehow had turned out to be a positive number, and damn, that was a big eraser. If this somehow turned out to be a positive number, and then when you looked at it, you were like, negative 1.6, I got 11.18. How the the hell did that happen? Go like this. Negative. Just make it negative because this sign here and this sign here ought to agree. If that one's positive, then that one should be positive. Okay, it'll never happen that they're opposite. Okay. Now, where does that negative 11.18 fall? You got to put it somewhere on this chart. Where does it fall?
All the way
It's all the way out in here somewhere, way out there. And it's actually like over here, I believe, if we're honest about it. -1, -2, -3, -11 is way off the screen. But it's in the shaded area. Do we agree? So with that being said, we're going to reject HO. Okay. Now, if I reject HO, one of the things that you'll see me do a lot is, if I reject HO, I'll say that this is false and this is true. I'm not saying that that's exactly accurate. Okay, I'm not saying that this is false, this is true. That's, you can always do that, because if it's the other way around, it's actually not very right to say that. But for the purposes of our understanding, that's what I'm going to go with. Okay, this is false, this is true. Which one's the claim? This is the claim, right? So is the claim true or false? It's true. So at a 0.05 level of significance, there is sufficient evidence to support the claim that mu is less than 30. Part G. You'll see it on your sheet of paper. Since n is greater than 30, the sample mean is normally distributed. Since n is greater than 30, the sample mean is normally distributed. Okay. Yes.
So if it were going to be that you failed to reject HO, what would we have gotten?
We don't support the claim.
Okay, but what number would you have gotten?
Oh, you would have gotten something less than negative 1.645. Like negative 1.1, negative 0.3.
Oh, okay.
Something that was less than, or greater than, I guess I should say.
Okay.
Yeah, it acts as a number line.
Okay.
For those of you that didn't hear the question, what would have happened for you to say, instead of reject HO, fail to reject HO? And in order for you to fail to reject HO, then this answer here has to be something like, negative, if this were like negative 1.2. Negative 1.2, here's 0, negative 1.2 is outside the rejection area, so you would fail to reject HO at that point.
Okay.
Okay.
I thought you had to get exactly 1.645, but
No, in fact, if you get exactly 1.645 and you fall right on the line itself, flip a coin. Because then you're neither in the rejection region nor outside the rejection region, and you would just flip a coin at that point. It never happens on test day. I ain't having a bunch of people flipping coins. Okay. All right. Now, how is this one different? Notice in this case, sigma is known. In this case, sigma is unknown. We use S. So, same basic thing. Test the claim. Amount's less than 30 minutes. So, here we go. Part A. HO is that mu equals 30. H1 is that mu is less than 30. Part B, we're using a one-tail test. It's a left-tail test still. This area is still 0.05. But because sigma is unknown, now we're using a t-score. Now, you ought to know which chart you're going to use because I tell you t equals. That's a clue. Hey, I think I should use a t-score this time. Yeah, that's a clue. So go into the t-score chart, looking up 0.05, degrees of freedom is 4. Typically I'd call on somebody for that, but I'm not going to call on you today for it. I'm just giving it out. Degrees of freedom is n minus 1. In this case, degrees of freedom is 4. Going to 0.05, one tail. we get 2.132. Yep. Part C is t equals x bar minus mu over s divided by the square root of n. Part D, t equals 20 minus 30 divided by 6 over the square root of 5. I think you get negative 3.75? 3.73. Okay. All right, so now you plot that on your chart, negative 3.73. You will, well, that's reject HO still. Okay, so if you reject HO, you're saying that this is false, that this is true. Fortunately for us, we know that H1 is the claim. If H1 is the claim, part F says you're going to support the claim. So at a 0.05 level of significance, there is sufficient evidence to support the claim that mu is less than 30. Part G, population is normally distributed and sigma is unknown. Any questions on that?